And I'm going to say this, part of what you just described, the other thing that needs to happen is that expert needs to be challenged
Mm,
too, because
yeah.
so many of the biases of 30 years of doing something a
Right.
certain way
Right.
was based on data, and you were only able to measure this much
Right.
of the data, not
Right.
this much.
Right. Right.
And so I think the next step of that is,
Yeah.
okay,
Yeah.
we got to really make sure that expert is right. One of the things I've noticed is a lot of times when we'll take over operations of a field,
Mm-hmm.
and you literally change the incentive structure for a pumper from, I want so many barrels of oil a day, to giving them their own little profitability statement.
Right.
They always run the pumps slower. They make a little less oil, but they spend way less on upkeep
Yeah. Yeah.
and,
Yeah.
and
Exactly.
everything. Yeah. So,
That's a great point. I'll give you an example around that. There was, you see, today what we have in operations, right? Whether it's refining or chemicals or whatever it might be, you have different functions. For example, you have reliability team typically consisting of mechanical engineers. You have electrical engineers who are monitoring electrical equipment. You have chemical engineers doing process work, right? And so you have all these different functions, right? Now, the profitability of your operation is not going to be based on just keeping the machines running all the time, because you can keep the machines running all the time, but if it's consuming more energy, more raw material, more fuel, it's still not
shortening
profitable.
equipment time.
Exactly,
Yeah.
exactly. So the point is, if you want to really improve the profitability, you have to look at it holistically, right? Which is exactly what you said. You just can't run it all the time to pump, more oil, but you have to actually look at optimizing it, right? And so the challenge though is, when we have a case where a customer came to us and said, that team was reliability team. They told me that, hey, we have a pump that's failing every 9 months, and we want to resolve that, but we replace it and it still keeps failing, and there's nothing wrong with the pump. So we said, okay, let's look at it as a system, and let's look at what's around it. And then we took all the data and the sensor information around, not just a pump, but the reboiler, the tower, because it was a bottoms pump in a tower, and put it in the application. And we showed them that, hey, it was essentially a reboiler that was fouling, which is causing polymerization in the tower, which is making the fluid really viscous and thick. And that was essentially what is causing the pump to fail. And then the mechanical engineer was super happy. He said, well, now I know it's not my problem. It's actually the process engineer's problem. But the point is, it's, unless you're trying to look at it holistically, right? You're not going to go to the next level of efficiency, because we have reached a stagnation point where every function is using their own little tools, right? There are point tools for different functions, and they're using those, and it's great, for what they have been doing so far. But if you want to break that ceiling and you want to achieve that next level of efficiency and operational excellence, you got to look at them, together. And typically, the reason why experts are counted in gold, or counted as gold, is because they are typically the ones who do that kind of work, right? And that's what we want the application to do by connecting those dots.
I'll tell you my favorite kind of data story, because you've been talking to experts, and I totally get we need to capture and all that. But the other thing too, with the level of detail now in data that we have, and just the computing power, being able to look at it.
Mm-hmm.
One of my favorite stories is, I'm going to kind of change the details to protect the innocent, but one of the large oil and gas companies hired a data scientist from like HEB,
Mm-hmm.
someone who knew nothing about oil and gas. I think this person was maybe 25.
I think I
And
know where this is going, but yeah, go on. Yeah.
well, and so anyway, one of the things they wanted to look at was expenses basically surrounding the pumpers, truck costs,
Yeah.
all this sort of stuff. And she studied the data and came back and just said, if a pumper will never put their truck in reverse, I forget what the stats were. It was like, it'll drop operating expenses 75% and it'll drop REX 44% or vice versa, whatever it is. And, the old pumper's like, what the fuck are you talking about? Hell, that ain't right. Well, so anyway, they just redesigned, a couple of pumpers' routes, and you never went into reverse, and the numbers were almost exactly right.
Right.
It's amazing how just looking at the whole with just pure data.
Exactly. I mean, there are, like you said, there are ways that people are used to working, and there's a reason for why, people work the way they do today, right? But it doesn't necessarily mean that there are better ways. The constraints that people had when they designed the systems, the way they're using it now, they might not be there today. And I think, many of these technology tools are helping them figure out what those, the new normal for operation could be.